Hello there. In this video, the first video, I want to talk about number systems. To get us off on the right foot, I want us to be able to use vocabulary accurately and to set a foundation for the rest of the videos to come. So I'm going to talk about number system because there's nothing more foundational to math than using numbers and understanding the vocabulary involved there. So the first number system we have is the natural numbers. The natural numbers are often noted with like a block letter N, and these are just the counting numbers. So counting numbers being 1, 2, 3, ... I once had a professor in college that would define 0 to be a natural number. I'm wondering if anybody's ever experienced the same thing. Often in the textbooks that we find natural numbers to not define 0 as a natural number. So I'm interested, leave a comment saying whether or not you've ever defined 0 to be a natural number. But that leads us into the whole numbers. The whole numbers are the counting numbers plus 0. And this is where we can start to see the building blocks of numbers. We're just taking the previous set of natural numbers and adding an element to it, which would be 0, 3, and then so forth and so on. That leads us into the integers. The integers is the natural numbers, or rather, the whole numbers plus their additive inverses, or their opposites, in other words. So that means we're going off in the negative direction, so I'll do a ... from there. Then we can say -2, -1, 0, 1, and 2, and so on. Now this is where it gets interesting because the rational numbers are just a set of numbers and written that can be written as a reduced fraction of integers. This is a very, very strict definition that we need for certain theorems, especially the fundamental theorem of arithmetic that I can get into in a later video. But numbers that can be written as a reduced fraction of integers, non-reducible fractions of integers are also rational numbers, but the point there is that they can always be reduced down. And so this includes numbers like 1/2, -3/4, maybe 7/8. You get the idea. 1 4/5 would be one, because this can always be written as 9/5. So those are rational numbers, and that leads us into our final set. The first set that we discuss, I don't know why I said final set, it's not our final set, but it's the first set that doesn't build off the previous, but rather deviates and becomes its own thing. So these are numbers that cannot be written as a reduced fraction of integers. And oftentimes there are mathematical proofs involved in demonstrating that these are indeed irrational numbers. Now, this is a contrast. Rational numbers and irrational numbers cannot coexist together. There is no number that is both rational and irrational. Rational numbers often have decimals that either repeat, so that might be 0.3 repeating, which is 1/3 as a fraction, or they have decimals that terminate, say 0.5, that's 1/2. Irrational numbers have decimals that extend forever, but with no discernible repeated pattern. And I say repeated pattern because there's a famous number, 0.1, 2, 3, 4, 5, 6, 7, 9, 10, 11, ... You can see the pattern involved in what that decimal, but this is also an irrational number because it can't be written as a reduced fraction of integers. Some other famous irrational numbers include the square root of 2. In fact, the square root of any number that is not a perfect square will be irrational. So square root of 3, square root of 5, square root of 27, so forth and so on. The most famous irrational number is pi. And then we've got another famous constant, e. Then there's the golden ratio, which is equal to 1 plus the square root of 5/2. Those are some famous irrational numbers. And this leads us to probably the most famous number set, the real numbers. This is just the combined set the combined set of rational and irrational numbers. There's one more we're going to get into. We're going to talk about complex numbers. And complex numbers, I'm going to get into this in a future video, but complex numbers are in the form a plus bi, where a and b belong to the real number. So the notation I'm using here, this little e-looking thing, means an element of, means it belongs to the set, and this is the set of real numbers. And then I is equal to the square root of -1. Again, I will get more into that in a future video. Okay, so let's really quickly, I'm going to talk about the Venn diagram. So this might be the natural numbers. This is where you'll find your 1s, your 2s, your 3s, your 4s, so forth and so on. But encompassed by that is the set of whole numbers. So anything you can find in the natural numbers, you can also find the whole numbers with the added element of 0. Then you've got the integers. The little notation for that is like I always draw it as like a sideways I or a Z looking thing. That's your -1s, your -5s, your negative numbers. Anything that can be written as a natural number is also an integer, but can be distilled down further. And so when questions ask you, what number set does this belong to, they might ask you for all the number sets. So -2 belongs to integers, whereas 4 belongs to natural, whole, and integers. Or they just might ask you for the most basic set that it belongs to. Then you've got the rational numbers. The rational numbers, I believe, is usually denoted as some kind of Q, which I found interesting. I believe it just stands for quotient. That's your -3/4, your 1/2. If you get something like -12/3, we would put -12/3 in the integers because that's just equal to -4. And then off to the side here with no intersection, because rational and irrational numbers cannot be, rational numbers cannot be irrational, and so forth and so on. This is where you get your square roots of 2s, your pi's, your e's. I'll throw in a couple extra, the cube root of 500. This is this is the real numbers, that little r, and the notation for irrational is reals. We strike the rationals. And then on top of that is your complex number system. Even real numbers can be written as complex numbers with an imaginary part, the b being equal to 0. So that's all I have for you in this video. Leave a like, comment, subscribe. If you have a request for a future video, leave that in the comment section. Thanks for watching.